students, today I will discuss about the numericals regarding friction as well as the Newton's law of motion chapter. First question is that a horizontal force of 490 Newton is required to slide a sledge weighing 600 kilogram force over a flat surface. Calculate the coefficient of friction. Here the horizontal force 490 Newton is given. So applied force is 490 Newton, and weight is a 600 kilogram force, that is W. This is F. You can write this is F, and weight W equal to 600 kilogram force. That is the kilogram force is the unit of force which is given in gravitational unit. That is kilogram force is called gravitational unit of force, and Newton is called, we know that Newton is called absolute unit of force. And calculate the coefficient of friction. We know the coefficient of friction is written as mu. So mu is the quantity that is the unitless quantity, that is the ratio of force and the normal reaction. We know that the formula for calculating the coefficient of friction, which I have discussed earlier, that is F equal to mu into R, where F is the frictional force and mu is coefficient of friction, R is normal reaction, and mu equal to, so F by R. So mu is the ratio of the frictional force and the R is the normal reaction. Here F is the frictional force, which should be equal to the applied force, because a horizontal force 490 Newton is required to slide a sledge weighing 600 kilogram force. So if 490 Newton force is required to slide the sledge, then the applied force minimum should be equal to the frictional force. That's why the applied force equal to the frictional force, and we have to take this value 490 in the frictional force, that is in a relation F equal to mu R. So we can write instead of F, that is 490 Newton, and R, that is the normal reaction. R is the normal reaction, and it is equal to the weight of the sledge, and obviously the direction of the normal reaction is opposite to the direction of weight. Just it is opposite direction, and it is equal value of the weight. So R equal to normal reaction, that is equal to W, that is 600 kgf. And since the frictional force is taken in the unit of Newton, so we have to take the R in terms of the unit of Newton. We know that 1 kgf equal to 9.8 Newton. So we can write R as 600 into 9.8 Newton. So the R is converted to the absolute unit of force, that is Newton. So instead of R, we can write 600 into 9.8. And if you take cutting of numerator and denominator, then we can write that is 1 by 12. 1 by 12, mu equal to 1 by 12, and this is equal to 0.083. By calculating, we can get 0.083. This is the value of mu, and it is unitless quantity since it is the ratio of two forces, that is F and R. And I hope you have understood this numericals and the solving method of the numerical problem. Next numericals is from the chapter Newton's laws of motion, and the numericals is a force of 10 Newton acts on a body for 3 microsecond, mu s, that is microsecond. Calculate the impulse. If mass of the body is 5 gram, calculate the change of velocity. And you have to first calculate the impulse. Here which quantities are given, you have to enlist the quantities given and not given. That is a force F, F is given, that is 10 Newton, and time is 3 microsecond, and you have to convert the microsecond into second. We know that microsecond, 1 microsecond equal to 10 to the power minus 6 second. So 3 microsecond is equal to 3 into 10 to the power minus 6. Micro means 10 to the power minus 6. So 3 into 10 to the power minus 6 second, and calculate the impulse. I is impulse. So you have to find out at first the impulse. Impulse is, we know the impulse is the product of large force and very small time. When large amount of force is applied in very small time duration, then the product of the large force and very small time is called the impulse. So I can be written as force into time, and we can take instead of F, we can take that is 10 Newton, and instead of T we can write 3 into 10 to the power minus 6 second. The impulse, unit of impulse will be, that is Newton second. So it will become, that is 30 into 10 to the power minus 6 Newton per second, and 3 into 10 to the power minus 7 second. Okay. So this is the answer, that is this is 10 to the power minus 5 second, 3 into 10 to the power minus 5 Newton second. Now we have to calculate the change of velocity. What will be the change of velocity? At first we have to know what is the relation between the change of velocity and impulse. We have already found out the value of the impulse, and we know that I equal to F into T, that is force into time, and according to Newton's second law, F equal to dp dt. dp dt means rate of change of momentum. dp is the change of momentum, dt is the time. So we can write F into dt, that is dp. So rate of change of momentum equal to force into time. So we can or we can write for this we can write for very small amount of time, that is dt. We can take also I equal to f dt. So f dt equal to dp, that is the change of momentum. Change of momentum. If you calculate the impulse, then you can also find out the momentum. That because the value of the impulse is equal to the change of momentum. So we have already find out the change of momentum. Then from the change of momentum we can easily find out the change of velocity. As we know that the momentum equal to mass into velocity, that is the we can write a change of momentum is equal to final momentum minus initial momentum. So we can write that is if you take the velocity, the final velocity is v2 and initial velocity is v1, and the mass of the object is constant, so final momentum is m. Let the mass of the body is n, and so initial momentum is mv1. So change of momentum is mv2 minus mv1. So you are taking, you have to take the common term as m. So m into, we can get that term m into v2 minus v1. So I equal to m into v2 minus v1. You have to put the value of I, and mass is given, that is the 5 gram. You have to convert the mass into kilogram, that is the 5 by 1000, that is the 5 into 10 to the power minus 3, and impulse is 3 into 10 to the power minus 5 into, that is v2 minus v1. So v2 minus v1 will be 3 into 10 to the power minus 5 divided by 5 into 10 to the power minus 3. So the 3 by 5, we can get the it will be the value equal to 3 by 5 equal to 10 to the power minus 2. So what is the decimal value of 3 by 5? That is 0.6 into 10 to the power minus 2. Okay, and this is meter per second. So if you take the decimal 1 point later, that is that will be 6 into 10 to the power minus 3 meter per second. This is the answer of velocity change, 6 into 10 to the power minus 3 meter per second. That is the answer of change of velocity. So this is the process how to solve this numerical, and I hope you have easily understood the solving method of this numerical step by step. Okay, now the class is over. Thank you students, and stay safe, stay home. Okay, thank you.